Two towers, 110 stories each, 1,368 feet and 1,362 feet tall. The tallest buildings on Earth when they were finished, built on a structural system no engineer had ever tried at that scale, anchored to bedrock 70 feet below a piece of Manhattan that wasn't even real land. It was landfill, and the Hudson River was right there, pressing against the site, waiting to flood everything the moment somebody dug too deep. They pulled it off anyway. 7 years, 200,000 tons of steel, and a wall built using an Italian technique that had never been attempted at anything close to this size in America. This is the story of how the Twin Towers were built. And I used AI to bring their construction process to life, so let's get into it. The idea for a World Trade Center had been floating around since 1946, but nothing happened for years. Downtown Manhattan was losing ground to Midtown, and David Rockefeller, who ran Chase Manhattan Bank, decided something drastic was needed. In 1958, he founded the Downtown Lower Manhattan Association and pushed for a massive trade complex. The Port Authority of New York and New Jersey took on the project after a deal that included taking over the bankrupt Hudson and Manhattan Railroad. The site chosen was Radio Row, a dense neighborhood of over 400 electronics merchants. When they learned the whole area would be demolished, shopkeeper Oscar Nadell led a committee that staged a mock funeral through the streets, carrying a black coffin with a sign, "Here lies Mr. Small Businessman." Lawsuits went to the Supreme Court. The court declined to intervene. On March 21, 1966, wrecking crews began tearing buildings down. The Port Authority had selected architect Minoru Yamasaki in 1962. They wanted 10 million square feet of office space. The only way to fit that much without making every floor dark and bloated was to go vertical. 110 stories each. Yamasaki, who was afraid of heights, designed the windows just 18 inches wide so occupants would always feel a wall within reach. The structural engineering fell to Worthington, Skilling, Hella, and Jackson, with Leslie Robertson leading the effort. They developed a tube frame system that had never been used on a building this tall. Instead of packing the interior with heavy, load-bearing columns, they concentrated support in two places. A dense grid of exterior columns spaced just over 3 feet apart around the perimeter, and a rectangular core at the center of each floor, holding elevators and stairwells. Between those two structures, every floor was open, column-free space. It was lighter than traditional construction, which meant the towers would move more in high winds. Robertson ran extensive wind tunnel tests to keep the sway within limits that wouldn't make people on the upper floors nauseous. The elevator problem was just as difficult. A conventional shaft layout for a building that tall would have eaten most of the usable floor area. The solution was sky lobbies on the 44th and 78th floors. Express elevators carried passengers to the sky lobby, where they transferred to local elevators serving each zone. That system cut roughly 70% of the shaft space a conventional layout would have needed. Construction started with a problem that had nothing to do with height. The entire site sat on landfill. Manhattan's natural shoreline ran roughly along Greenwich Street, several hundred feet east of where the towers would stand. Everything west of that line had been dumped into the Hudson over centuries. Ship ballast, demolition rubble, dredged river muck. Below all of it, bedrock sat 70 feet down. And the Hudson River was pushing against the western edge of the site, ready to pour in the moment anyone dug a hole. The site was threaded with old water mains, cables, and pipes that all had to be relocated before excavation could begin. You cannot build the tallest structures in the world on loose fill with a river pressing against the foundation. The answer was the slurry wall, a technique developed in Italy in the 1950s for the Milan subway. Nobody had tried it at anything close to this size in the United States. In 1964, the Port Authority sent engineer George Tamaro to Italy to study the method. By 1967, Tamaro was running the operation himself. Here is how it worked. Crews dug a trench 3 feet wide, 22 feet long, and 70 feet deep along the site's perimeter. As they dug, they continuously pumped in bentonite slurry, a dense liquid clay that was heavier than the surrounding soil and groundwater. The weight of the slurry held the trench walls in place and kept the river from flooding in. If the pumps fell behind, even briefly, water pressure from the Hudson could have collapsed the trench and flooded the excavation. The crews ran the slurry operation around the clock. Once a section reached bedrock, workers lowered it in a steel reinforcing cage that could weigh up to 22 tons. Positioning these cages into a 70-foot deep slot, only 3 feet wide, required precision that left almost no room for error. Then concrete was pumped in from the bottom of the trench, pushing the slurry up and out as it filled the space. When the concrete hardened, it formed a permanent watertight wall bonded to the bedrock. They repeated this 158 times, panel by panel, section by section, until the deep basement area of the site was sealed inside what the engineers called the bathtub. The 3-foot thick wall ran nearly 3,400 linear feet and went 70 feet straight down into the earth, enclosing 11 of the site's 16 acres. With the bathtub sealed, crews started excavating everything inside it. They pulled out 1.2 million cubic yards of earth, old fill, and centuries of accumulated debris. As they dug deeper, they installed high-strength steel tieback anchors through the slurry wall and drove them up to 35 feet into the bedrock on the other side to brace the wall against the enormous lateral pressure of the surrounding ground and river water. 1,500 of these anchors were installed at intervals as the excavation went down, each one capable of handling loads between 100 and 300 tons. Rather than trucking all that material to a landfill, the Port Authority barged it to the Hudson River shoreline and used it to extend Manhattan 700 feet westward. That new land eventually became Battery Park City, an entire neighborhood built on the dirt pulled from the World Trade Center hole. Steel erection on the North Tower began in August 1968. The South Tower followed in January 1969. Both towers would consume more than 200,000 tons of structural steel sourced from at least 7 foundries spread across the country. That was more steel than went into the Verrazano Narrows Bridge. The components were prefabricated off-site to keep the schedule tight and the quality consistent. Perimeter wall sections arrived as 3-story tall panels with the columns and spandrel plates already welded together at the factory. Each panel weighed up to 22 tons and had to be hoisted, positioned, and bolted into place while hanging from a crane hundreds of feet in the air. Floor trusses came pre-assembled, designed to span the 60 feet between the perimeter wall and the core, without any intermediate columns. Steel arrived by rail to Jersey City, then by truck or barge to the site, which had almost no room to stockpile material. Pieces had to arrive and get set on nearly the same day. Getting those pieces to the top of a building that would eventually stand 110 stories tall required a crane that did not exist in the American market. Carl Koch Erecting Company, the steel contractor, brought in hydraulic cranes designed by Favel Mort in New South Wales, Australia. The workers called them kangaroo cranes. They could lift heavier loads than a conventional derrick, and they had a trick no standard crane could match. They could raise themselves up the building's core as the structure grew, jumping several floors at a time using their own hydraulic power. Each tower had 4 kangaroo cranes, one positioned at each corner of the elevator core, working simultaneously at different heights. 8 cranes in total across both towers. When conditions were good, crews set the steel for 3 floors every 2 weeks. Conditions were frequently not good. The Australian cranes had radiators designed for mild climates, and the hydraulic oil froze in New York winters. The pumps turned out to be untested prototypes that the manufacturer had swapped in at the last minute to hit the required lifting speeds. Automatic welding machines that were supposed to accelerate the ironwork never ran reliably and had to be abandoned entirely in favor of manual welders. Koch Erecting realized within months that it had massively underbid the contract and nearly went bankrupt before the steel was even halfway up. In 1970, a tugboat strike shut the harbor. The Port Authority tried helicopters to move steel, but one lost its load into the waterway and the idea was abandoned. crews could only set whatever pieces were already staged on site. Despite all of that, the ironworkers kept climbing. These were men who walked steel beams at 1,000 feet with a hard hat as their only protection. Falls were the most common cause of death on the project. There were no safety nets for much of the construction. The wind at those heights was constant and brutal, strong enough to knock a man sideways if he wasn't braced for it. The North Tower topped out on December 23, 1970. The South Tower reached its full height on July 19, 1971. For the first time in nearly 40 years, the Empire State Building was no longer the tallest thing on the New York skyline. The view from Midtown had permanently changed. The first tenants moved into the lower floors of the North Tower in December 1970, while ironworkers were still setting steel on the upper floors. The South Tower accepted its first tenants in January 1972. Construction and occupancy overlapped for years. People rode elevators to their offices in the morning, while welders sparked above them, and concrete trucks poured on floors a few stories up. The numbers on the fit-out were staggering. Each tower had 99 elevators, including express cars that traveled at 1,600 feet per minute, the fastest in the world at that time. The buildings contained 425,000 cubic yards of concrete, 3,000 miles of electrical wiring, 40,000 doors, and 43,600 windows. 6 acres of marble were installed across the lobbies. The mechanical systems alone could fill their own documentary. A central chilling plant below the complex produced enough cooling for 15,000 homes. Diesel generators stored enough fuel for 48 hours of backup power. Below street level, the complex housed a shopping mall, a 2,000-car parking garage, a station for the PATH commuter rail connecting to New Jersey, an armory for the Secret Service, and a police precinct. The South Tower's rooftop observation deck sat 1,362 feet above the street, and an indoor deck opened on the 107th floor of the same building. The exterior cladding went on in parallel with the interior fit-out. The aluminum alloy panels that covered the perimeter columns gave the towers their distinctive vertical ribbing. Each panel had to be hoisted, fitted, and sealed against wind and rain at heights where the wind was never predictable. Workers installing windows and cladding on the upper floors dealt with gusts that could rip unsecured material right off the building. The towers were not loved when they opened. Ada Louise Huxtable of the New York Times called the design pure technology, with lobbies of pure schmaltz. Others dismissed them as oversized filing cabinets. They also sat largely empty. The Port Authority had to fill them with its own offices and state agencies just to avoid the embarrassment of obviously vacant floors. The formal dedication happened on April 4, 1973. Both governors attended. President Nixon sent a statement. The ceremony was brief and polite. Behind it was a project that had cost well over $1 billion against an original budget of $400 million, taken 7 years, employed more than 10,000 workers at various stages, with 3,500 on site at peak, and killed 60 people through falls, equipment failures, and blasts. The towers filled up over the following decades. By the 1990s, the complex housed over 430 companies from 28 countries, and 50,000 people went to work there every day. The engineering legacy went further than the buildings themselves. The tube frame structure became a standard approach for super-tall construction worldwide. The slurry wall technique was adopted for deep urban excavations across the country. The sky lobby concept showed up in towers from Chicago to Kuala Lumpur. The buildings stood for 28 years. They are not there anymore. 7 years of construction, 60 lives. A neighborhood erased, a skyline remade, and a piece of land pulled straight out of the Hudson River that is still there today. But the foundations held. The slurry wall, the bathtub that George Tomorrow built starting in 1967, survived. It is still holding back the river, 70 feet below the memorial that stands where the towers used to be. If this caught your attention, hit subscribe and give this video a like. And let me know in the comments what construction story, place, or era do you want me to cover next. See you in the next video.